Okay, so this time I'm going to move on to RAC database management. And where are the location of data files, undo files, and system files, control files, and archive files? That's what we will have to discuss. And we will have to discuss a few important files. So I'm going to actually get into class note. And this is an example of a two-node RAC database. And I want to actually write down here. Suppose that you have a host 01 and host 02. So this is my host, and also I have a host 02. And where is the location of your database files? And the bottom of this page, I will consider this as shared storage. Okay, so in order to understand this part, we will have to understand database structures. Database structure or structures. So when you create Oracle database, and what are the files that belong to Oracle database? That's what we have to discuss. And the first thing is, in order to start Oracle database, no mount state, we need either P file or SP file. And also, in order to start database mount state, I need the control files. In order to open your database, I need the online redo files. And also, I need the data files. And I also need maybe a password file. And also, I need archived log files. And what else? Let me see. I have archived log file. And also, I have a network configuration file. And I have more files. Okay. So where are the location of these files? Easiest way to understand is this. Out of this location, these files, control file and online redo and data files, these are the mandatory files of Oracle database, which means that these files must be in the shared storage. So which means that in this case, in the shared storage, I must have control file. And if this is ASM storage, you have a multiplexed ASM disk group, the multiplexed control files across 2 or 3 ASM disk groups. And also, online redo files must be the multiplexed across ASM disk groups if this were ASM storage. And also, data files, the data files are stored in the shared storage. And what about password file? And password file, it can be local storage because it is optional. Archived log file, it can be local storage because it is optional. Network configuration file, it's optional, and we store in the local storage. And P file, SP file, this is optional, so we can create P file and SP file in the shared, in the local storage as well. But that's a possibility. But what is the recommendation? The recommendation is, even the optional files, it's a good idea to store in the shared storage as well. So, for example, you create SP file in the shared storage, but create P file in the local storage. P file in the local storage here and here. So P file store only one entry, which is a pointer to SP file. Okay, so that's your SP file. And also archive log file. You can also create archived log file in the local storage as well. Okay, but there are more actually configuration and concerns. So it's a good idea to store archive logo file in the shared storage as well. So the best practice is, unless you have a special region, create P file in the local storage as a pointer to SP file, okay, and create archive logo file in the shared storage for simpler management. And what about password file? And we used to have a password file or a PW file in the local storage, but starting with the 12C, and we place in a password file in the shared storage as well. Okay, so in addition to these mandatory files, and you can also create optional files in the shared storage as well. Okay, so now let's get into this. Read logo files and RAC. And this example, so where is the location of the redo logo file? This is this location, shared storage. So we are in the shared storage, and we have a read logo file. Okay, if you have instance 1 here, and you have instance 2 in this location, then you will have a log writer in each instance. So we have a log writer. So log writer running out of here, log writer is running out of here. And this log writer will write redo to online redo logo file. Okay, in order to assign set of online redo files to each instance, assigning the ownership, you will have to group set of online redo files with thread. So for example, just like in our slide here, and we have thread number 1, and then we assign the group number 1, 2, 3, and all 3 groups are the members of a thread 1, and we assigned it to a RAC 1 instance. So how did you assign? Look at this. We use init parameter, and thread equals to 1, and this is assigned to RAC 01. And also, we have a group 4 and group 5 that belong to thread 2, and we assigned it to RAC 02. So we have an ownership in this way. So instance 1 can read and write to thread 1, and instance 2 can read and write to thread 2. And also instance 1 has read permission to thread 2. Instance 2 has a read permission to thread 1. And as a part of an instance recovery or database recovery, instance may have to access to a group of online reader files owned by another instance. So this is the region. Now, in this particular example, we have different configuration. Thread 1, it consists of 3 online reader groups. Thread 2, we have 2 groups. Is this recommended? Or it is, are there any regions? It depending on your workload distribution. If you have an application that is connected from connection pool, we equally made a connection, okay, from connection pool, okay. If 2 servers are equally loaded and you expect same pattern of workload, then you should have the same identical the online redo groups in each thread. But you may want to actually create 2 different services in instance 1 and instance 2 to isolate traffic. So you may need more activities in one of the instances. So by doing so, to support the instance that generate more redo, you may want to have one more online redo group, something like that. So it depending on how you partition your workload. So you can have an identical configuration, or you can have a slightly different configuration. So this is also supported. Another thing what you have to know is, we discussed about database type. So let's come back to this location. We had a discussion of admin manage the database and policy manage the database. suppose that you are adding one more instance here. So you added the host 04 and you added the additional instance here. That means a log writer from newly added instance also generate redo. Where does it go? It goes to online redo group in a specific thread that was assigned to the instance 4. Did you create? No, I didn't create. Then you will get error. So you will have to create online redo groups for fourth instance. If your database type is admin managed database. However, if your database is a policy managed database, then when adding additional server, your database instance will be added. And that time, thread is automatically enabled if your file location is ASM or storage that enabled that leverages OMF. So with the policy management, you can manage online redo files easier because thread will be enabled automatically. Okay, so now let's get into this. We also have undo management. And you can create many number of undo table spaces. In the 2-node RAC database, you can create 3 undo table spaces, not a problem. But you can activate only 1 undo table space per active instance. If you have 2 instances, then you can only use 2 active undo instances, undo table spaces. In this example, undo TBS1 was assigned to RAC1, undo TBS2 assigned to RAC02. Even though you have additional undo table spaces, this is not in use. Now, I have one small discussion on this area. So let's take a look at this example. I'm going to start this whiteboard node again. And I have lesson 4 discussion. Let's take a look at this. Okay, so this is an undo table space. And this is to go over undo purpose. What was the purpose of undo? And we already know what is the purpose of undo. It is to support read consistency. It is also to support recovery. And also it is for flashback. And we use undo for different purposes. So for example here, in this particular example, I have session 1. This session 1 issued an update statement at time t1, for example. I have an app01 data file, undo tbs01.dbf file. At time t1, I issued an update statement to update data in the app01.dbf. If that is the case, what will happen? And this database block will be cached in memory. So in this example, we have a database in the bottom and the buffer cache above. So we cache the database block, and then we will make some change here. So let's say I'm going to make it in A. I better say B, for example. Originally, I had an A in the database block, and then I updated it to B. But I didn't commit yet. So when I issued the select statement at time t2, what will be returned? Even though it is before the commit, the B will be returned. Makes sense. I'm the updater. Even though I didn't commit, I should be able to return the current data. Now, I made another session in the right-hand side, session 2. At time t3, I issued a select statement. Which value will be returned? Now, since session 2 is not updated, I need the before data, which is the value A. Question is, where can I read this value A? Is it from physical structure, physical database, or is it from memory? Where can I get this value A? Based on the background, you probably understand where to get value A. Okay, in this diagram, we missed the one step, right? Before update A to B, we had to copy before image of data, which is A, and this is copied to undo block. So we generate undo, but it doesn't mean that we read value A from undo. The feature that allows you to read value A in undo block, that is a flashback. Okay, but Session 2 cannot read this value A from undo block. Instead, we will have to copy database block that contains uncommitted transaction. So we did a copy here. And then we will have to apply undo to roll it back. And your value A is from copied block, and this is called consistent read block. That is the idea. Okay? Now think about this way, and the time when you updated 1,000 blocks, for example. And before the update, you issued a full table scan to run in a query for reporting. That means I have to create 1,000 consistent read blocks. Okay? Do you see a problem here? If you leave uncommitted transaction for a long time, we have a chance to create consistent read blocks eating up memory structure and consuming CPU time. If this were a RAC environment, so for example, you have a 3-node cluster, you did an update statement, you did another update statement, in third instance, you issue the full table scan. Then we have to create consistent read block, and there will be undo block transfer, and also consistent read block transfer. So it's a good idea to commit your transaction timely manner to reduce block transfer. So we will have to understand this basic idea here. And another concept here is when you actually issue commit statement at time T1, that means we make this undo unexpired. Or when you roll back, we apply undo back to original database block. That's the meaning of a rollback. So we use undo not only for flashback, we also use undo for recovery and to provide the read consistency and also the rollback. So there are actually many of the usage of undo. So that's what we have to understand. Let's come back. So we had enough discussion from here. Now, let's get into a local temporary table space. It is a 12.2 new feature. What is the purpose of a temporary table space? That's what we have to learn first. So let's take a look at this. Class node, and I'm going to add one more page. Okay, so it is for memory intensive operation. Okay, that's the purpose of temporary table space. And for example, sorting is one example. And another example, maybe hash join. And another example could be bitmap related operation. Okay? And whenever actually possible, we perform all this information directly in the PGA. But PGA space is a limited memory space. It's in the physical RAM in the compute node. But what if you have to store more data than the memory space available? Then we have to do disk sort, and we have to perform disk-related operation. And we do perform this operation in the temporary table space. Okay? And if you have actually the RAC database, let's say instance 1, instance 2, instance 3, 3-node RAC database, and you can only create temporary table space in the shared storage, and this will be used by all the instances. So that is shared temporary table space. And let's go back here. In this example, all data files, and these are all in the shared storage. So temp file also shared by all instances. But starting with 12.2, we have a new concept, local temporary table space. Why do I need it? And we have in a brief the review of lesson 3 concept. If you remember in lesson 3, we learned that it's possible to start database instance in the leaf node. And this diagram is giving you a single cluster that consists of a 3 hub node and 2 leaf node. Prior to 12.2, we only could create database instances in the hub node. That's it. So this example, 3-node cluster. But starting with the 12.2, you can create read-only instances in the leaf node. And that is called reader node. That's the name of instance. In this particular example, we have host shadow 4, host shadow 5, and I have an instance here. Okay? I can make 5-node instance, 5-node RAC database, and 3 instances are read-write, and 2 instances read-only. And what is the purpose of instance in the leaf node? Again, this is a new support from 12.2. This is a review. The main purpose is I want to perform some I/O-intensive operation here, or memory-intensive operation here. So, as a part of it, I may need a sorting operation. I may need the PGA. I may need the join related space here. So I need the memory space or disk space for the memory-intensive operation. So in that case, what happened is these instances can leverage shared temporary table space in ASM storage. That's already possible. However, we want to also leverage the local storage available. Because host shadow 4, we have a local storage attached. So I want to create temporary table space in the storage that is local to host shadow 4. And also, I want to create temporary table space in the storage that is local to host shadow 5. So that way, when sorting is needed, but there is not enough memory space, I want to directly write it to local storage instead of access to shared temporary table space in ASM storage. That is actually one concept. So in this case, let's go back here. Local temporary table spaces were introduced in Oracle Database 12.2. I/O is improved by writing spillovers to the local disks on the reader node, read-only instance. This is a new support. And local temporary table spaces improve temporary table space management in read-only instances. That's what I mentioned. And storing temporary the files in the reader node private storage to take advantage of I/O benefit. And avoiding expensive cross-instance temporary table space management. And it improves instance warm-up performance by eliminating on-disk space metadata management. You cannot use local temporary table space to store database objects such as tables or indexes. Makes sense. Temporary table space is only for temporary operation. Okay, this is an example of creating temporary table space. The first example is we want to create local temporary table spaces only in the leaf node. So we have a keyword here, for leaf. This example is identical to this example. In the host shell 4, host shell 5, we have read-only instances, create local temporary table spaces only for instances running in the leaf node. Or you have an option here, for all. No. I want to create local temporary table spaces, not only read-only instance location, but also read-write instance location as well. So we have one of the two options. And if you have a local temporary table space and share the temporary table space, which one will be used first? For read-only instance, local temporary table space always highest priority. In the read-write instance, using shared temporary table space is highest priority. So, depending on your instance mode, we can leverage a local temporary table space first, or share the temporary table space the next. So that's what we can manage, and that's internally decided. And also, instance cannot share local temporary table space, and one instance cannot use a local temporary table space from another because it is a private space. If an instance runs out of a temporary table space during scaling, then statement results in error. Makes sense. You don't have a space, you will get error. Only one big file per local temporary table space is allowed. So we use a big file table space. And also, to address contention issue, multiple local temporary table space can be assigned to different users. So we can actually create the temporary table space, and then we can assign it to different users. And user can have two default temporary table spaces. One is the local default temporary table space, and another default, which is a shared default temporary table space. So you have actually two default temporary table spaces. And if you need more space, if you need additional management, use alter database command and alter table space command to increase the size of a temporary table space, and also to change the auto extension attribute, and to decrease the size to make temporary table space offline or online. So you can use alter table space and alter database command. And we have a nice view that gives you temporary table space, name, and shared or local temporary table space indication, and also instance where the temporary table spaces are available, or local temporary table space are available. So we use a DBA view, and also user view also available, and you can use different views to see not only local temporary table space, but also share the temporary table space. Okay, so the second section was the database management. We learned the location of Oracle database files, and also what are the mandatory files that must be stored in the shared location, and what could be stored in the local storage, but better to be in the shared storage. And also we had a discussion of the online redo management, and also undo table space management and concept of undo table space, and with the read-only instance, which is a new support in 12c, how we can leverage a local storage for spillover operation, like temporary operation. We can create local temporary table space, or if you are working on read-write tables, read-write instances, then you can also leverage shared temporary table space as well. And this is second part of this lesson. Okay, so let's get into part 3, instance management. In RAC environment, and there are multiple instances as an access point to Oracle database. And you can manage RAC instances using SQL+, and also using SRV-CTA utility, and also using Enterprise Manager. Personally, I prefer, my preference is SRV-CTL, because you can start up instance with the flexible options. And if you control instances using SQL+, you have to change the Oracle seed, and you have to get into the location where instance is running to control. So the command must be executed. And also, when you start a RAC database instance, you can actually start all instances of a database simultaneously, or you can only start selected instance using SRV-CTL or Enterprise Manager, or using SQL+. And in the single instance database, what is the meaning of a shutdown transactional. In the single instance database, when you issue shutdown transactional command, and we wait until our active transaction is complete, and then shut down database instance. But if you run same shutdown transactional command in RAC environment, we have to wait for active transactions across instances. So it will take long time to shut down database instance. So if your intention is only wait for active transactions of the connected database instance, then you will have to add a local option. Okay, shutdown transactional local. And you can also shut down database. Meaning that you can shutting down all instances of a database. And this is an example of stopping and starting RAC database instances using SRV-CTL. You have SRV-CTL and start and stop instance and database option. And also, you can add a start option and stop option as well, just like this example. Start option, and stop option. And also in the example, this is to start ORCL1, ORCL2 instances of ORCL database. And you can also stop 2 instances. And you can start database up to mount to state. And you can also start database instance in a specific node. And this example, last example, is an example of a RAC 1 node example. So with a RAC 1 node, you keep only a single active instance, and you can specify where to start RAC 1 node instance. So you can specify host information and node information. And this is an example of a controlling RAC instance with a SQL+. Once you get into host, and you have to change Oracle seed, and you log in as a sysdba to shut down and start up. And if you want to manage a second instance, you have to connect to host 02 and change the Oracle seed, and you control RAC instance. And starting and stopping pluggable databases in Oracle RAC. Manage RAC PDBs by managing services regardless whether they are policy or administrator managed. Assign one database service to each PDB, coordinate start and stop and placement of a PDB across instances. And this is an example of the adding new service for PDB. Service name in this example is PLUG, and it is to connect to Spark PDB database. I didn't cover multi-tenant database yet, but for your information, multi-tenant container database is database consolidation solution. And this database consists of SP file to start database normal to state, control file to mount your database, and also online redo logo files. And up to this point, it's the same as the standard architecture. And the only difference is data files. And your data files, logically table spaces, are grouped together at the container level. Container is a group of table spaces. So by default, there is a root container that keeps system table space, undo table space, and sysaux table space, and so on. And also, there are one or more user containers as well. And user containers are called pluggable databases. When you start up database instance with a multi-tenant architecture, SP file is scanned to start your database normal to state, and then read the open control file to mount your database, and also open control file, open online redo logo file, and open data files that belong to root container. So only system data files are available. Now, if you wanna start pluggable databases automatically at instance startup time, one option is you create non-default PDB service. So clusterware will attempt to start required resource to start database service. So in this example, when you start database instance, and in this PDB, we created a plug service, and clusterware will check status of a required resource, which means the database in this example, PDB. If a PDB is not open, to start plug service, clusterware will automatically start PDB database, and then make plug service available. And we will get into this area in one of our lessons. We have one lesson about multi-tenant architecture in RAC environment. You can also start and stop service using srvctl start and stop command. And also, we can get database configuration information. srvctl configure database -all, show me all information. And let's take a look at one by one. So here, this is my database name, DB unique name. And this is my DB name, Oracle database home, and Oracle home owner, SP file. As you can see, my SP file location is shared location. And also password file is in the shared location. When you run srvctl to start database, and always open option is default. When you stop database, shutdown immediate is the default option. And ORCL database is a primary database. And management policy is automatic, meaning that when you restart clusterware, clusterware will restore your database status as is. For example, before stopping clusterware, your database was a shutdown state, okay, on purpose. Next time when you restart clusterware, your database will be shut down state as it is. And also, your database was up and running and you restarted the clusterware, and clusterware will remember the previous database status, and if this was open, then when you restart clusterware, your database will be started automatically. And if you want to manage a database manually on purpose as part of a maintenance purpose, then you can set it to manual as well. And this slide is giving you RAC init parameter file. We had a discussion. P file is stored in the local storage, and P file is used as a pointer to SP file in the shared storage. Okay, so that is a best practice. It doesn't mean that that's the only option, but that's a recommended option. And just like in a single instance database, by issuing alter system set command, you can change the various parameters, either at memory level or with the scope equals to memory. But difference is, you will have to add SID information. If you want to apply certain parameter settings specific to instance, then you will have to add SID, SID, SID. Where do you want to apply these parameter settings? So you add SID to specify where to apply changes to. That's what you have to add. And you can also manage and view SP file parameter values from Enterprise Manager. So in the init parameter location, you have various parameters. So you have in a search engine, you enter a keyword to display changes, to display parameters based on that keyword. And also, we have the cluster keyword, and it will show you all cluster-related parameters. And certain parameters can be modified, and certain parameters cannot be modified. And we also have a list of parameters here. And there are parameters that require identical setting. So these are all parameters that must be identical, meaning that in your init file, you will have to asterisk and parameter equals to value. So these parameters must be applicable to all instances. Compatible must be identical. Cluster database, do you want to enable clustering of instances? Yes or no? And control file, block size, and DB domain, and number of data files, DB name, and faster recovery area, and its size, and these all must be same. And also instance type, and parallel execution message size, and authentication method with the password file, undo management, and all these parameters must be same. However, and these parameters must be unique. So for these parameters, you will have to add specific value. For example, I have ORCL1 dot ORCL2 dot. Okay, instance name must be unique. Instance number must be unique, and undo table space must be different. So you can activate one undo table space per instance, and your cluster interconnect must be unique, and rollback segment must be unique if you are using rollback segment. So these are parameters that must be unique. Okay, so up to this point is instance management. We learned that how to start RAC instances, what is the meaning of starting RAC instances, what is the meaning of shutting down RAC instances, and also what would be a nice tool to control instance startup and instance shutdown, how you configure RAC instances, what other parameters must be unique, and what are the parameters that must be unique for instance management. And this is a part 3.